Okay, I'm going to show you an interesting relationship between the circumcenter, centroid, incenter, and orthocenter in some special triangles. In particular, an isosceles triangle. These two angles up here are the actual measures of these two base angles are here. And you can see, since these two angles are congruent, we have an isosceles triangle right now with B as the vertex angle. And hopefully you can see in this diagram here, as soon as I make the triangle isosceles, we have a very interesting relationship between all 4 points, not just the circumcenter, centroid, and orthocenter, but all 4 points, even the incenter as well. And notice, all I have to do is make it a little cockeyed in here, making it scalene, and we now have the points as a team of 4. They are not collinear anymore. Notice, no matter what triangle I draw in here, they're not lining up unless it is an isosceles triangle. I'm going to try to make it isosceles again by looking at these numbers. It's a little difficult to do, to keep on tinkering with these numbers. There we go. Whoop, right there. And so now we have an interesting question. What type of triangle would it be where all 4 points are on top of each other? So right now all 4 of them are on the same exact segment. In fact, if you think about it, the segment that I'm trying to draw here with my mouse, this segment right here would be the median, it would be the altitude, it'd be an angle bisector, and it would also be an angle bisector. And again, it only occurs that this segment is all 4 segments when we have an isosceles triangle drawing these segments from the vertex angle. And so what type of triangle would we have if we have all 4 points on top of each other? Well, that's right, we have an equilateral triangle. I'm trying to squeeze these points together, but at the same time I'm looking at those angles posted up there. I'm trying to make it's really difficult. It's so sensitive. So hopefully you can see I've gotten really close to 60, 60, and 60. I've given up right now on this very sensitive piece of software. But when all the triangle is equilateral, we have all 4 points on top of each other. So a little summary. When we have an isosceles triangle, we have all 4 points collinear. That means the median, altitude, angle bisector, and perpendicular bisector are actually on top of each other. And when we have an equilateral triangle, that's when all 4 points are actually located in the same exact spot. All right?